All right, problem 10. So in this question, basically we have several integers like 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, 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 all the way through 2021. And then we're gonna do something to those numbers. So we're gonna remove the first number there, keep the second number, remove the third number, keep the fourth number, remove the fifth number, keep the sixth number. So after that step, the numbers that are left are just all the even numbers. So 2, 4, 6, 8, blah, blah, blah. They're going to be left. And we have removed all of the odd numbers. That's the first step. And then for the second step, we do the same thing. We're going to remove the first number here, keep the second, remove the third, keep the fourth. So after that step, we're left with basically just multiples of 4. So 4, 8, and the next one's 12, blah, blah, blah. Just keeps going. And then we do it again, right? We remove the first number, keep the second number. So now the first number, so 8 is left there, and the next one is probably 16. So these numbers are all multiples of 8. So here we already found some pattern, right? If you just look at our numbers, like after each step, we see that after the first step, the first number there is 2 to the power of 1, which is just 2. After the second step, the first number there is 2 to the power of 2. And the next step, after the next step, the first number is 2 to the power of 3. So that's our pattern. And it just keeps going like that. So we know that after the 10th step, the first number that's left there should be 2 to the power of 10, which is 1024. But then we know that so after that step, all of the numbers left should be multiples of 1024. But there's only one number, right? Only one number below 2021 that is a multiple of 2 to the power of 10. So that's the only number left there. So the question asks us what is the sum of the digits of n. Then we simply do this 1 plus 0 plus 2 plus 4. So that is 7. So that's the answer here. Well, the reason we stop at 2 to the power of 10 is that if we go to 2 to the power of 11, then that's already 2048, which is beyond 2021. So that number is just not in our list. So that's why we stopped at 2 to the power of 10. All right, problem 11. So we know the three heights of the triangle ABC. There are 12, 15, and 20. And we like to find the area of the triangle ABC. So the key point to this question is we're able to find the ratio of the three sides of triangle ABC using the three heights there. So let's assume this 12 is the height that corresponds to BC. So 12 is HA is equal to 12. Well, HA is the height that corresponds to the side BC. HB is equal to 15, and HC is equal to 20. All right, so now we have the nice relationship that this BC times HA is equal to CA times HB, which is equal to AB times HC, because each of them is twice of the area of triangle ABC. Let's say the area is S. So they're all equal to 2 times S. All right, then we can plug in some numbers. So 12 times BC, that's equal to 15 times CA, and that's equal to 20 times HC. Sorry, 20 times AB. And they're all equal to 2S. Okay, so now we can find the ratio of the three sides there. BC, the ratio of BC, CA, and AB, that's just 2S divided by 12, 2S divided by 15, and 2S divided by 20. And then we can simplify the ratio. So first of all, they all have 2S there. So they just got canceled out. So the ratio is just the ratio of 1 over 12, 1 over 15, and 1 over 20. And then we can multiply everything by the least common multiple of those three numbers, of those three denominators, because we definitely prefer working with integers than working with fractions. So the least common multiple of those three numbers is 60. So let's multiply everything by 60. We have 60 over 12, 60 over 15, 60 over 20. But that's just the ratio of 5, 4, and 3. All right, so the ratio of the three sides of triangle ABC is just 5, 4, and 3. That sounds familiar, right? So if the ratio of the three sides is just 5, 4, and 3, then that's actually a right triangle. Because from the Pythagorean theorem, we know that if we have like a squared is equal to b squared plus c squared, then the triangle is the right triangle. Okay, so now let me draw a right triangle there. So BC is 5, CA is 4, AB is 3. So it seems that BC is the hypotenuse and CA is the longer leg there. So let's do this. So the ratio is like 3, 4, and 5. All right, if we look at this triangle here, it's a right triangle. So we already know the two heights there, right? AB is a height, AC is a height. So AB is height, AC is also height. And we have another height. Let's draw a line segment that is perpendicular to BC from point A. So AD is also a height here. We know the three heights are just 12, 15, and 20. So if you look at the graph here, AD is definitely the shortest. So that should be 12. And then AC is the longest, so that should be 20. And AB is the one in the middle, so it should be 15. Okay, so the question is what's the area of triangle ABC? Since it's a right triangle, we know the area S is simply 1/2 times AB times AC. So that's equal to 150. So that's the answer to this question. So we should select E there. Okay, problem 12. So this problem is about arithmetic progressions in the Fibonacci sequence. Basically, we want to find the number of arithmetic progressions in like the first 100 or 101 terms in this Fibonacci sequence. So let's start by writing down the first several terms of the Fibonacci sequence and see what kind of arithmetic progressions there are. Okay, so I'm going to write down the first several terms. The first term is 0, and then it's 1, 1 and 2, and 3, and 5, and 8. All right, so let's stop there and let's see what arithmetic progressions we have there. So first of all, I see this 0, 1, 2. We have another 0, 1, 2 because there are just two ones. Also, we have two 1, 2, 3. So 1, 2, 3, 1, 2, 3. Also, we have 1, 3, 5. 1, 3, 5, 1, 3, 5. And finally, we have 2, 5, 8. 2, 5, 8. Okay, seems that's it. That's all the arithmetic progression we have within the first 7 terms of the Fibonacci sequence. So I guess we already start to see some patterns. So if you look at the last 2 progressions there, 2, 5, 8, 1, 3, 5, it seems that they have the same pattern, right? And actually that is true in general. So let's show that if we have Fn, Fn minus 1, and Fn minus 3, Fn minus 1, we skip n minus 2, and then we have Fn minus 3. So let's show that these 3 numbers actually form a arithmetic sequence. It's not hard to show that because that simply follows from the definition of Fibonacci sequence. So we have Fn minus Fn minus 1. That's equal to Fn minus 2. But we also know that Fn minus 2 is equal to Fn minus 1 minus Fn minus 3. Okay, so the difference here is equal to the difference here. That just shows those 3 numbers form arithmetic sequence. Okay, so basically that means if we add another number there, like the next term F7, which is equal to 13, then we're gonna have one more arithmetic sequence, which is 3, 8, and 13. Right, the common difference is 5 there. And if you think about it, the 3, 8, 13 is the only arithmetic sequence ending with 13. That's because if you want to have an arithmetic sequence there, you got to have the second term to be the term next to 13, because otherwise your first 2 terms are going to be too small to form an arithmetic sequence with the last number there. So from now on, whenever we add one more term, then we're going to have one more arithmetic progression. So let's see, how many arithmetic progressions are there? 1, 2, 3, 4, 5, 6, 7, 8. So the last term is F7 here, and we have 8 arithmetic progressions. So what we want is, so the last term there is like F of 100, F100. Then there should be 101 arithmetic progressions, because you see there's like a +1 relationship. So F7 and 8 arithmetic progressions. So if it's F100, then there should be 101 arithmetic progressions. So the answer here is A, 101. Okay, question 13. So in this question, we have a circle O and 2 points B and C on the circle. Point A is inside the circle. We also know that angle B is equal to angle A is equal to 60 degrees. We know the length of AB is equal to 8. The length of BC is equal to 12. And then we want to find out the area of the circle. So of course, we only need to find the radius of the circle, and then we can do the pi r squared. Okay, so the first thing I would like to do is to extend AO to the point D on BC. So the reason we do it is because angle B and angle A, both of them are 60 degrees. So if we extend AO to the point D, we have the triangle ABD is an equilateral triangle. Equilateral triangle is definitely very nice. For example, we immediately get that the angle D here, angle ADB, is also 60 degrees. We also know that BD is equal to BA, and that's equal to 8. So we can update our information here a little bit. We know BC is equal to 12, and BD is equal to 8. That means CD is equal to 4. So we have BD is equal to 8, and CD is equal to 4. Okay, so now let's think about how we can find the radius of the circle. One method is to use the length of the chord and also the distance from the center of the circle to that chord. And then we can use Pythagorean theorem to find the radius of the circle. So now let's find the midpoint of BC. Let's say it's M. So M is midpoint of BC. Since it's a midpoint, we know this BM is equal to 1/2 times BC. So that's 6. BM is equal to 6. That means MD is equal to 2 because the total length of BD is equal to 8. So we have BM is equal to 6 and MD is equal to 2. So if we connect O and M, we know that OM is perpendicular to BC because M is the midpoint of the chord BC. All right, now we have a nice right triangle there, the triangle ODM. We know that MD is equal to 2. And also, this is a 30, 60, 90 degree triangle. So this is 30, 60 degrees, 90 degrees triangle. And then we can find the length of the side lengths of that triangle. So OM should be equal to √3 times the length of MD. So that is 2 times square root of 3. 2 times square root of 3. Okay, we're almost done. Just one last step. Now, if we look at the triangle OCM, we know that OM is perpendicular to CM. So this is a right triangle, and we can use Pythagorean theorem there. So OC squared is equal to CM squared plus MO squared. CM is equal to 6, so that's 36. MO is 2√3, so the square of that is 12. And we get 48. We don't need to take the square root of this because what we want is the area of the circle. Area is equal to pi times the radius squared, and that's simply 48 pi. So the answer is B. Question 14. So we have two sets of points. Set A is given by points x, y that satisfy the absolute value of x plus absolute value of y is equal to A. And set B is about all points x, y such that the absolute value of x times y plus 1 is equal to absolute value of x plus absolute value of y. So what we want is the intersection of A and B. It should be 8 vertices of a regular octagon. And then want to find values of A such that this is gonna happen. So first of all, let's figure out what those two sets are. We can start with set A. So set A is about points such that absolute value of x plus absolute value of y is equal to A. A is a positive number here. So since we have some absolute values there, we can look at the graph of this equation based on where the points are, like whether it's in the first quadrant or second quadrant, things like that. So if the points are in the first quadrant, then we know x and y are both greater than 0. So first quadrant, then the equation becomes x plus y is equal to A. So that is aligned with slope -1, and we can draw it on the coordinate plane. Similarly, we can look at the second quadrant there, where x is smaller than 0 and y is greater than 0. So our equation becomes y minus x is equal to A. This is aligned with slope +1. And we can also draw it on the coordinate plane there. And similarly, we can look at the third quadrant, the fourth quadrant, and we're going to find that the graph of this equation is actually a square. The sides of the square have slope +1 and -1. And the intercept are like A, -A, and also on the y-axis, there's also A and -A. Okay, now let's look at the set B. So the equation is x times y, and then take the absolute value +1. That's equal to absolute value of x plus absolute value of y. We can factor this equation. So absolute value of x minus 1 times absolute value of y minus 1. That's equal to 0. So we have either absolute value of x is equal to 1, or the absolute value of y is equal to 1. Okay, so set B consists of 4 lines, and the 4 lines are x is equal to 1, x is equal to -1, y is equal to 1, and y is equal to -1. Let me draw those 4 lines there. Cool. This is y is equal to 1, y is equal to -1, x is equal to 1, and x is equal to -1. Okay, so now let's put A and B together, and we want there to be 8 vertices, 8 intersection points, and we want those 8 points to be the vertices of a regular octagon. Okay, so let me copy the graph of B, and then we're going to try to put the graph of A on top of it. Let's copy. All right, so now let's see how can we put A on top of this graph so that the 8 intersection points are the vertices of a regular octagon. All right, so I'm gonna draw a square like that. This one looks good, right? We have the 8 intersection points are those 8 points. They look like the 8 vertices of a regular octagon. So, for example, we have point A here, point B, point C. So what we want is this AB is equal to BC, because the octagon is regular. So now we can find the coordinates of those points. So for point A, we know that it's on the line x is equal to -1. So x is -1. And what about y? Well, so the point A is also on this line here. And the equation of this line is y is equal to x plus a. So y is equal to -1 plus a. That's the coordinates of point A. For the point B, we know that, first of all, it's on the line y is equal to 1. And it's also on the line y is equal to x plus a. So 1 is equal to x plus a. That means x is equal to 1 minus a. And finally, point C. So point C is on the line y is equal to 1. It's also on the line x plus y is equal to a. So x should be equal to a minus 1. Okay, so we know the coordinates of those 3 points. So we should be able to find the distance between, for example, BC and AB. So the distance between BC is simply the x-coordinate of C minus the x-coordinate of B. So that's a minus 1 minus 1 minus a. So that's 2 times a minus 1. That's the length of BC. We also want to find the length of AB. But notice that this is 45, 45, 90 degree triangle. So the length of AB is simply √2 times the leg of this right triangle. And the leg of this right triangle is just the x-coordinate of B minus the x-coordinate of A. So x-coordinate of B minus the x-coordinate of A. So that's 2 minus A. Now we want BC equal AB. So we have 2 times A minus 1. That's equal to √2 times 2 minus A. Let's rearrange this a little bit. So we have 2 plus √2 times A. That's equal to 2 √2 plus 2. So A is equal to square root of 2. You see that when a is equal to square root of 2, we have 2 times root 2 here, and we have 2 here. So that's one of the solutions there. A is equal to square root of 2. So there might be another one. Let's see. So I'm going to copy the graph here. All right, so another case is we have a very large square there. And that might also work. So for example, we have we have a point A here, point B here, and point C there. So the 8 points are, these 8 points. And it might be possible, right? It might be possible for those 8 points to be the 8 vertices of a regular octagon. So here, again, we want AB to be equal to BC. So let's try to find coordinates of those points. So for A, y is equal to 1. This is pretty similar to what we did for the previous case. So y is equal to 1. And the point A is also on the line y is equal to x plus a. So x is equal to 1 minus a. That's point A. Then for point B, we know x is equal to -1. Since B is also on the line y is equal to x plus a. So y is equal to -1 plus a. And finally, on point C, we have x is equal to 1. And the y coordinate, well, the point C is on the line x plus y is equal to a. So y is equal to a minus 1. Okay, so again, we can have an equation for a from AB is equal to BC. So BC is equal to 2, right? The x coordinate of C is 1, the x coordinate of B is -1, so BC is equal to 2. AB is equal to, again, this is the right isosceles triangle. So AB is equal to square root root 2 times the x coordinate of B minus the x coordinate of A. So root 2 times the x coordinate of B, which is -1, minus the x coordinate of A, which is 1 minus A. Okay, so we have an equation for A. So 2 is equal to square root of 2 times A minus 2. So that gives us A is equal to 2 plus square root of 2. Okay, so now we have two values of A. The two values are root 2 and 2 plus root 2. We want to find the sum of all possible values of A. So let's take the sum, and that's equal to 2 plus 2 times root 2, which is roughly 5, because root 2 is like 1.4 something. So the answer is 5. Okay, problem 15. So we randomly choose two numbers x, y between 0 and 1. What is the probability that none of these two numbers is the median of the following set? So the set is we have x there, y there, And we also have 1/2, 1/4, and 1/8. All right, so here we can use the coordinate plane to help us visualize what x and y satisfy that condition. So we're going to focus on the region where x is between 0 and 1, and y is also between 0 and 1. So we have like 3 cases, because if none of x and y is median, then the median must be 1/2, 1/4, or 1/8. So 3 cases. First case, median is equal to 1/2. Cool. So we put 1/8 here, 1/4 here, and 1/2. So if we want 1/2 to be the median, then x and y should be on the right of 1/2, which means x and y are larger than 1/2. So we can find those x and y on the coordinate plane. X is larger than 1/2, y is also larger than 1/2. So we can draw the 2 lines, x is equal to 1/2, y is equal to 1/2. Then the red region here, the region here consists of points with x larger than 1/2 and y larger than 1/2. Okay, second case, median is equal to 1/4. We know 1/8 is to the left of 1/4, and 1/2 is to the right of 1/4. So now, if we want this 1/4 to be the median of the set, then x and y should be on different sides of 1/4. So we have 2 cases. First case is x is smaller than 1/4, y is larger than 1/4, or x is larger than 1/4 and y is smaller than 1/4. So now let's find where those x and y are in the coordinate plane. We draw 2 lines, x is equal to 1/4, y is equal to 1/4. So first case, x is smaller than 1/4. So that's this part. And we also want y is larger than 1/4. So that's above this line. So what we have is this part of the region. And similarly, if x is greater than 1/4, y is less than 1/4, then that corresponds to this region. So that's the second case. And we have the third case, where median is equal to 1/8. Since we know that both 1/4 and 1/2 are larger than 1/8, and then if we want 1/8 to be the median, x and y should be both less than 1/8. So x and y should be here. So we have x is smaller than 1/8 and y is smaller than 1/8. Again, we can try to find the points on the coordinate plane. We can draw 2 lines, x is equal to 1/8 and y is equal to 1/8. So if we want x to be smaller than 1/8, then our region should be to the left of the vertical line here. If we want y smaller than 1/8, then our region should be below the horizontal line here. So what we have is this very small square at the corner. Okay, 3 cases. And now let's just compute the probability of each one. So we can think of the probability as the ratio of the area of the region to the whole square. Of course, the area of this whole square is equal to 1. So the probability is simply the area of the corresponding region. For the first case, our region is this red square. And the area of that is simply 1/2 times 1/2. And that's equal to 1/4. For the second case, we have the green region there. There are 2 of them, and each of them is a rectangle with side lengths 1/4 and 3/4. So the area is 2 times 1/4 times 3/4, and that's equal to 3/8. And finally, we have the last region there, the small purple square. And the area of that is 1/8 times 1/8. And that's equal to 1/64. And finally, we can just take the sum. So 1/4 plus 3/8 plus 1/64. That's equal to 16 plus 24 plus 1/64, which is 41/64. So the answer is D. All right, so problem 16. So we have 3 friends A, B, and C. They're playing chess. Every 2 of them play once. For each game, the winner gets 2 points, the loser gets 0 point, and if it's a tie, then each player gets 1 point. And you want to know the different arrangements of scores after those 3 games. All right, so first of all, we notice that for each game, the sum of the points for the 2 players is always 2. Right? It doesn't matter whether there's a winner, there's a loser, or there's a tie. The sum of the points is always equal to 2 for a single game. So with 3 games, the sum of the scores should be equal to 6. So A plus B plus C must be equal to 6. Because for each game, there are 2 points. All right, and then we also know that since each of them only plays 2 games, that means the maximum they can get is just 4 points. You cannot get 5 points or 6 points. So we know that A, B, C, all 3 numbers are at most 4. All right, so with those 2 conditions, let's see what different arrangements we can have. So we can do some casework here. We can do our casework based on the maximum of those 3 numbers, A, B, and C, the largest number there. So if the largest number is 4, then I guess there are maybe 2 cases. One is A, B, C, the 3 numbers are 4, 2, 0. This is definitely possible because this guy can just win 2 games, and for the game between those 2 guys, one of them wins, so he's gonna get 2 points, and the other loses again. He will get 0. So this is definitely possible, and the number of different arrangements there is just 6 because it's 3 factorial. So 3 factorial, that's equal to 6. Second case, the largest of A, B, C is still 4, but then it could be 1 and 1 for the rest of the 2 scores. This is also possible, right? Because this guy can win 2 games, and for the 3rd game, it's a tie. So there are 3 cases there. Because so A, B, and C any of them can get this 4 points. So 3 cases. All right, then we're done with the cases where the largest of those 3 numbers is equal to 4. So then let's move on to the case where the largest number is 3. So first of all, we have 330. That is possible because these two people can both beat the third guy. Well, they can tie their own game. So that's how they can get 330. Again, there are 3 cases because this 0 can be A, B, or C, and the rest of the 2 people should be 3. Okay, so 3 cases. And next one, we have 3, 2, 1. That's the distribution of scores. This is also possible because maybe the first guy beat the second guy beat the third guy. Well, the first guy and the third guy, they have a tie. So that's how they got 3, 2, and 1. So it's possible, and there are 6 cases. Again, 3 factorial. All right, so then what do we have? I guess that's it for the cases where the largest number is 3, and we have one last case where the largest number is just 2. So that means all 3 numbers are 2. This is definitely possible because all the games can end up with a tie. So that's how they can get 2 scores. All of them got 2 scores. So there's only one case because just all of A, B, C, they have 2 points. All right, so that's it, and we can take the sum. So 6 plus 3 plus 3 plus 6 plus 1, and that's 19. So the answer is B, 19. Problem 17. So this is an analytical geometry question. We have an ellipse, x squared over 16 plus y squared over 9 is equal to 1. And let's first draw that ellipse. So we have the xy coordinates there, x, y. And we see that this ellipse passes through some points, right? For example, 4, 0, negative 4, 0, 0, 3. Also 0, negative 3. So so the ellipse should look like this one. Something like that. Okay. So we have another line. The line is x over 4 plus y over 3 is equal to 1. We also notice that the point 4, 0 and the point 0, 3, those 2 points are also on this line. So let me draw the line there. It passes through 2 of the points there that are also intersections of the ellipse and the axis. Okay, so we have a line, we have the ellipse. And then P1 and P2 are 2 points on the ellipse such that the area of triangle P1AB and the area of triangle P2AB are both 6. And we want to find the area of the quadrilateral AB P1, P2. So then, so now let's try to figure out where P1 is and where P2 is. Well, the area of the triangle P1AB is equal to the area of the triangle P2AB, and that's equal to 6. But actually, there's a third triangle in this graph whose area is also 6. So that is the triangle formed by the two intersection points and also the origin. So let's give those points some names. For example, we have, we already have names. So that's A, that's B, and also the origin is O. So we know that OA is equal to 3, OB is equal to 4, and this is a right triangle. So the area of triangle OAB is also equal to 6. Okay, now we know where P1 and P2 are, because since the area of those three triangles are all the same, we know that the distance from O to the edge AB should be the same as the distance from P1 to AB, which is the same as the distance from P2 to AB, which means the line O, P1, P2 should be parallel to AB. So that's how we got our points P1 and P2. So we just draw a line through the origin that is parallel to our given line. So let me draw the line here. Let's say our original line is L1 and our new line is L2. And the two intersections are P1 and P2. Okay, L2 is parallel to L1. L2 also passes through the origin. L2 passes through origin. Cool. Now let's try to find the equation for L2. We know the equation for L1. That's x over 4 plus y over 3 is equal to 1. If we want L2 to be parallel to L1, then we'd better have x over 4 plus y over 3, like the same as the equation for L1. We only need to change the constant. Since the origin is on L2, we know that when x is equal to 0, y is equal to 0, then the equation should be true. So that's why we need to put a 0 on the right-hand side. Okay, now we have the equation for L2. And our next task is to find the coordinates for P1 and P2. Okay, so we have the equation of the ellipse, x squared over 16 plus y squared over 9 is equal to 1. We also have the equation for L2, x over 4 plus y over 3, that's equal to 0. We only need to solve this system of equations. So we're going to have two solutions. So one of them is x is equal to 4 over root 2. Y is equal to negative 3 over root 2. The other solution is x is equal to negative 4 over root 2, and y is equal to 3 over root 2. Okay, so basically it's because x over 4 and y over 3, they are negation of each other, right? So that means the square of x over 4 and the square of y over 3, they're the same. But their sum is equal to 1. So each of them should be 1/2. That's why we have these two solutions. Okay, so with that, we're able to find the length of P1, P2. So P1, P2 is equal to, we can just use Pythagorean theorem. So square root of x1 minus x2 squared plus y1 minus y2 squared. All right, what is that? X1 minus x2, that's actually just 2 times x1 squared. So we have 32 there, plus y1 minus y2 squared. That will give us 18. So then we have 5 times square root of 50, which is 5 times root 2. We're almost there. So we know P1, P2 is parallel to AB. So actually this quadrilateral is a trapezoid. And we know there's a formula for the area of the trapezoid. And we also know the height here. If you look at the triangle OAB, we know that AB times this height is equal to OA times OB. So the height here is equal to OA times OB divided by AB, which is 12 over 5. Now, basically, we know everything. So the area is equal to 1/2 times AB plus P1, P2, and then times height. So that's equal to 1/2 times 5 plus 5 root 2 times 12 over 5. So that's equal to 6 times 1 plus root 2. So the answer is D. Problem 18. So C is the largest integer such that the polynomial px is equal to x to the 6 minus a times x to the 4 plus bx squared plus c has 6 distinct integer roots that form an arithmetic sequence. So first of all, this polynomial only has even order terms. So that means if t is a root, then minus t is also a root. Okay, so now we can put the 6 roots on the number line. We have, let's say the 3 positive roots are x1, x2, x3. And then we know that negative x1, negative x2, and negative x3 are the other 3 roots. All right, now if you want those 6 roots to form an arithmetic sequence, then there's only one possibility, which is we need this x2 to be 3 times x1 and x3 to be 5 times x1. So that the common difference here is like 2 times x1. Okay, so now we can write our polynomial as px is equal to x minus x1 times x plus x1, x minus 3x1, x plus 3x1, and x minus 5x1 times x plus 5x1. So that's equal to x squared minus x1 squared times x squared minus 9x1 squared times x squared minus 25x1 squared. All right, so now we can simply expand this and compare the coefficients of corresponding terms. So we have A is equal to x1 squared plus 9x1 squared plus 25x1 squared, which is 35x1 squared. And C is equal to negative 1 times 9 times 25 times x1 to the power of 6. All right, so we want C to be as large as possible. But here we see that C is a negative number. So that means we want this x1, we want absolute value of x1 to be as small as possible. So x1 cannot be 0 since we can only have distinct roots there. So x1 cannot be 0. So that means this x1 should be equal to 1. So that's the smallest absolute value there. All right, and if x1 is equal to 1, we know that A is equal to 35. So the answer is B.